All right, now let's copy paste these values, okay, from train and from validate. Okay, so we have train. Okay, so predicted value and residual. Actually, we can calculate residual ourselves, right? So predicted and residuals. If you have the y values pasted here, we can calculate the residual ourselves. All right. So that's train. Then we have let's open the validate file. Okay. So again we have prediction and residual, those two, and we need the y values also a little bit later. So let's get that value, which is what, net v. Okay, so there it is. So let's get the y values also copied back in here. So these are the values that we need to do the rest of the computations. Let's go ahead and close all these other files. Alright, so we're going to use count of that. So that will give us the n value for train. Okay, so here the creation of the train and validate data sets is 60%, 40%. So it's not going to be the same 60%, same observations for you and for you and for you. It's going to be different because it is randomly selected. So some of these values may not be exact. Okay, so you may have 302 or something, or 299. Okay, so there may be slight difference because of the random nature of selecting the records. All right, so don't expect exactly the same number. Of course, P is going to be exactly the same. So here, if you go to results, let's keep the results open. Here, okay, so that's number of observations. So that's 301. Okay, so for validation, it is 205. Okay, and 13 is the number of predictors. So that would be 13, and here if you do count of the validation set, which is this, okay. All right. So degrees of freedom for error is n minus p minus 1, and this 13 includes the intercept also. So all you have to do is to go like that. Okay, and there is no degrees of p for validation because we did not use the validation set for developing the model for estimation. So there is no p for validation. So validation set, we're simply using it for computing these measures. Now SSE is the sum of squares of residuals, right? So the residuals are the E sub I values. So we have to square the E sub I values and add them up, and that would be SSE. So how do you do that? Well, of course, you can square each E and add them up, or the easier way to doing that is use sum SQ function. So sum SQ will simply square each of the cell values and add them up. Square and subsum squared values. So that is your sum of squared error. I'll tell you what, let's get this copied so we don't have to keep coming back to this window. So highlight all of those values and do Control C, and let's do Control V here. All right. So now it looks crazy, right? So to make sure that we have not messed up anything, did we mess up anything? Well, let's do this. No, I think it'll be all right. Okay. All right, so it's all crazy here. To clean it up, I would suggest that you clear the formats. If you clear formats, then it'll look a little bit better. Okay? All right. Okay, so clear formats. So now we really don't need these. Well, these two columns. So I'm going to clear that. So these are the error values, and here again we don't need NaN simply means it's not applicable. So what I'm going to do is I'm going to highlight this area and replace NaN. Well, actually we don't need this column. That is test. So do Control H and we'll replace NaN with blanks. Okay. So we won't have these NaNs popping around. Control H, find and replace. So find what? NaN, replace with what? Nothing. Okay. So replace all, that's gone. Alright, so now we have a clean looking, okay, let's clear that. Okay, so now SSE is right there, so that's your error function. Okay, so that's SSE. Error functions are calculated somewhat differently in classification, but in prediction, error function is simply SSE. Okay, and we do the same thing. Sum SQ for validate. All right, so you get 4375. Of course your number could be slightly different, but it should match with your SAS output, SAS results, right? Now average squared error is sum of squared error divided by n. So you take that and divide by n. So that is sum of squared error. Where is it? Sum of squared, well, average, sorry, average error function. So there it is. Okay. And the same value for average squared error. So error function, okay, that's sum of squared errors is the same, but in prediction, okay, error function is somewhat slightly different when it is classification. So here is sum of squared error. Now mean squared error is degrees of freedom for error that SSE divided by degrees of freedom for error. So that's your mean square error. Mean square error and average square error are the same for validation. So since validation there is no P, mean square error and average square error are the same thing. Okay, it's not different. It's different only in the training data set, because we use training data set to estimate the model, and therefore the mean square is different from average. Alright, root average is square root of the average, and root mean square is again square root of the mean square. Okay, and so here we have root average squared error. Okay, so that's that, and then root mean squared error.